I'm going to start working on drawing number 2.5, and what we want to do, of course, is we want to make sure it's taped down straight. So your parallel bar becomes the horizontal line. Make sure the parallel bar head is up against the edge of your drawing table. And then as you tape down your drawing sheet, make sure the black line on the border or here in the middle of the page lines up precisely and exactly with the black line that's printed. So I've done that. I've got tape on the four corners. The drawing can't move. I'm going to take my drafting powder and give it a little squeeze on the drawing. And then we're going to take a look and start up in the top left corner and work our way through the geometric instructions on this page. So the first problem is to inscribe a hexagon inside a radius 1 1/4 inch circle. Inscribing a hexagon. So we're going to do a couple of things. We're going to need to set up our compass up for a specific size, and that specific size is 1 1/4. And there's two ways to set the compass up to a specific size. One is the right way, one is the wrong way. I'm going to show you the right way first. The right way would be to get a piece of scrap paper, and on that scrap paper just draw yourself a line. And then take your scale and on that line measure off 1 1/4. Okay, so I've got two tick marks there showing me where 1 1/4 inches are. And then what you want to do is you want to take your compass and put the point of the compass on one of your tick marks and adjust the leg of the compass until the lead is touching the other tick mark. And you just set your compass to 1 1/4 inches. Now this is the proper way to set the compass distance. Let me show you the improper way. The improper way would be to grab your scale and jam the needle into the 0 and then move the leg, adjust the leg until the lead is touching the 1 1/4. Why is that a bad idea? Well, look, your needle on the compass is steel. Your scale is plastic. You're going to jam this in here 50 or 100 times, and pretty soon you'll have a crater where the 0 used to be. So the plastic tool cannot withstand multiple punctures from this thing. So if you want your tool to last, don't jam the compass into any of the marks, and don't drag the lead of the compass across the numbers because it'll get dirty. The dirt will get on your drawings, and then you're going to want to clean this with a little window cleaner maybe. And what you'll see is the ink inside these etchings will come out, and you'll have a bunch of white marks with no visible ink in there, and it'll be hard to read. So if you set it my way, that scale will last your entire career. I've got my compass set right now, and I'm going to put the center point exactly precisely on that little crosshair, that center mark. And I'm going to swing that 1 1/4 inch radius circle. And remember, when you are making circles, to lean the compass in the direction you are twisting it as you hold it by the top knurled edge with 2 fingers. Okay. Carefully put your compass to the side. We're going to need it again. What you want to do now is you want to use your parallel bar or your T-square, and you want to line up with the center of the circle and kind of bring that point out to the edge here. You want to find this point, this east quadrant location on that circle. Okay, and once you've done that, we're going to go back to our compass. Now, I haven't adjusted the compass. I haven't changed the radius at all. It's the same setting it was. And what I'm going to do is I'm going to put the point of the compass at the intersection of the circle and the line. Be really, really, really careful and precise. Okay, when you have precisely located the tip, make a little arc that crosses the circle. And then move your point to this new intersection of the circle and the arc. And make another arc. And then move your point to the next intersection. And of course, be as accurate and perfect and precise as you can. Because if you're off a little bit each time, by the time we get to the end, you're off a lot. We'll stick the needle in, make our next arc, stick the needle in at the intersection, make our next arc, and then what I should see is if I put the needle at that last arc, that it crosses over exactly and precisely my first point. Right, so there's this relationship, there's this weird relationship between a circle's circumference and its radius. You can step off that distance 6 times around the circle. Okay, and hexagons have 6 sides. So what we're going to do now is we're going to play connect the dots. Okay, so now that we've laid everything out lightly, we can go back in and we can get a nice dark pencil. And you should just be able to go around and connect dots, one dot to one dot and one dot to one dot, all the way around. But you know, there's another method of doing this too, and the other method is draw the circle, find the point here, and then a 60-degree angle should take you all the way around the circle. And here's what I mean. We start here, and we will go up till we hit the circle. And then we will go over to the left horizontally from where we hit the circle. And then we will go 60 degrees the other way. Until we hit the circle. And then I will flip it, and we'll go 60 degrees the other way until we hit the circle, and then we will go horizontal again, and we'll go 60 degrees for our last segment there, and our hexagon is constructed. So hexagon can go point to point to point 6 times around with 6 arcs, or it can just start here and go exactly 60, horizontal, 60, 60, horizontal, 60. Okay, inscribed means that the polygon is formed inside the circle. That's good to know because the next problem has you circumscribe a polygon. Okay, so circumscribe means go around the outside of the polygon. It's the same 1 1/4 inch radius. So I've already got my compass set. I'll make my circle nice and light. And then what we'll do is we will circumscribe around it. Now in this case, all I need to do is lightly plan out where is the tangency between the top and a line. So that's the point where the horizontal line perfectly touches the top of the circle. I'm going to try to do that here at the bottom also. I'm going to find that one location where I can draw a line, and the line perfectly touches the circle. I'm going to go back here and I'm going to do the same thing, but this time my horizontal is here and my triangle is sitting on top of it, and I'm going to make a 60-degree line that is tangent to the circle, and I'll come up here and I'll do the same thing. 60-degree line tangent to the circle. I'll flip the triangle. I'll do the same thing here. I'll make a 60-degree line tangent to the circle, and a final 60-degree line tangent to the circle. So now really lightly, what we laid out was a hexagon at either horizontal or 60-degree lines that perfectly tangentially touches all the edges of that circle. So now that you know where it is, you can go back in and you can darken. And darken those two. Darken this one and that one, and then darken our final two. We can check to see if it's a perfect polygon with dividers, because if it's a perfect polygon, you should be able to have the same exact distance on each edge. This word, circumscribe, describes that the polygon goes around a circle. Think of other words that begin with that prefix, circum. So how about circumference, right? Circumference means around a circle. Or how about circumnavigate? Like Magellan circumnavigated the globe. He sailed all around the earth, right? And of course, there's other words that have that prefix too, but we'll ignore them. You want to be aware, though, of the difference between inscribe and circumscribe, because look, they both started off with a 1 1/4 inch radius circle, but one of them is obviously much bigger than the other, right? And this will be important later on too when you are working in AutoCAD. You need to know the difference between inscribed and circumscribed polygons, because CAD software is going to ask you to specify what kind of polygon you want. Alright, going on. Our next task is to draw a hexagon on the base AB. Here is the base, and I want to create a hexagon, but I haven't been given a circle and I haven't been given a radius, I've just been given one edge. Well, that's easy. We can just take our compass to set this up. And what we're going to do is we're going to put the point at B. We're going to open the leg up to A, and then we're going to make an arc. And then we'll put the point at B, and then we'll put the point at A. And the lead should touch B, and we'll make an arc. And the magical spot is right there, right? Treasure map, there's the X. Now put the point at the intersection of the two arcs. Okay, and what we just did is we just started with this and we added the circle. And just like we were going to do with that first hexagon, now that we know where to start, we can position our compass point here and create an arc that crosses the line of the circle. And then we'll put the compass point here and create an arc that crosses the circle. And same thing, put the compass point here, make an arc that crosses the circle. Compass point here, arc that crosses the circle. And if we check it, our last point should land at A. Okay, and then it's go around and play connect the dots again. Okay, so that point to this point, and this point to that point. and this point to that point. And this point to that point. Okay, so we found the center point with a couple of arcs, and then we added our circle, and then we stepped off the 6 increments around the radius, around the circumference with the radius. Our task here is draw an octagon inside a 3-inch square. 3-inch square. All right, so there's a lot of ways of doing this. Maybe the easiest way, though, is to grab your scale. I'm going to use some very light layout. What I'm going to do is, I know 3 inches is the size I'm going for. I would like my square to be in the middle of this area, centered on that little center mark. So I'm going to take the number 3 and I'm going to cut it in half, and we can figure out that half of that is 1.5, right? So I'm going to put the 1.5 mark on my scale at this point. I'm going to put a small tick here and a small tick here at 3. So I'm putting a tick at 0 and a tick at 3. I have 1.5 inches here and 1.5 inches here, and altogether we have 3 inches, and that's centered on that center point. And then what I'll do is I'll go in with my triangle on top of my parallel bar, or my T-square, and I'm going to draw a light line on that mark, and then draw a light line on that mark. And what we should see is if we measure, we should have 3 inches exactly, right? And if you look, there's an equal amount on each side because we started in the middle and worked out from the middle. Okay, so that gave us 3 inches left to right. Now I need 3 inches up to down, top to bottom. Well, I can do this like that. Half of 3 is 1.5. So I will put the 1.5 on my center mark. I'll make a little dash at 0, small tick mark, and a small tick mark at 3. 1.5 and 1.5 is 3 altogether, and again they're both centered on that center mark in that direction. I'll add a line at each of those tick marks. And what I should have now when I look is I should have a 3-inch by 3-inch square. And that looks good. I'm happy with that. All right. So I made the 3-inch square. I need to construct an octagon that fits within that 3-inch square. You're going to use your compass to do this. And here's what you want to do. You're going to stick the point of the compass in the corner of the square. And then you're going to want to open the leg of your compass so that the lead is touching that center point. Okay. And when the point is in the corner and the lead is touching the center point, we're going to make 4 arcs. We're going to make an arc from this corner. And then without moving the compass setting, we're going to put the point here. We're going to make an arc from that corner. I'm going to put the point here. Make an arc at that corner. And then finally, we'll put the point here and make an arc from this corner. Now that's a pretty little flower shape, and if you're wondering what that has to do with an octagon, check it out. here's a flat edge, and then we're going to do a 45 degree here. And then a flat edge and a 45 degree, flat 45, and there's your 8 sides for your octagon. So now nice and dark. Nice dark line there. Nice dark line there. Nice dark line there. And here. And then you can either play connect the dots to draw this, but it should be 45 degrees if you laid it out properly. So we can go in there and set those up too. Perfect geometric constructions are a challenge because every little 5,000th of an inch you're off in one place will add up with the next error, with the next error, with the next error, and pretty soon you could be off quite a bit on your last location because all those errors accumulate. All right, and there is our hexagon inside a 3-inch square. Now this would be a good time probably to talk about erasing. We've got these two figures we just constructed, and I want you to look at them. When you darken them in, did they need a little bit of cleanup? Did you maybe darken something a little bit too far? Or did you maybe have a double line like I have there? So what we want to do in those cases is we want to bust out the erasing shield. And like right here, I over darkened the line. I went a little too far. So I'm going to cover over the good stuff. And I can see the stuff I want to get rid of. And then I'm going to erase through the slot in the shield so that I've got this perfect sharp corner. And I'd encourage you to take a look at your drawing and do the same thing. If you have anything that's a little too far, you went a little too far, a little too zealous with your darkening, have to go back in and clean things up a little bit, then use the erasing shield and the eraser. Here with this double line, I'm going to cover over the good part of the line. And I'm going to try to erase some of that extra thickness that I don't need. And there it is, nice and clean. Now, I laid everything out really lightly on the drawing, and you can easily see the dark lines of the solution I came up with. If your lines for laying things out are dark, I'd like you to go back in and I'd like you to erase them. Okay, so what would that mean? Well, imagine my light lines here are too dark. Well, you can go back in and you can erase until you get close to the figure. And then you can erase until you get close to the figure. Now, you don't want to get too close, because if you get too close, the chances are good you're going to accidentally use your eraser to erase part of the line you want to keep, right? So the solution to not doing that is to erase close to the figure, but then stop. And then for the last little bit, go back in with the erasing shield so that we don't accidentally wipe out the stuff that we want to keep. Okay, so you can use the eraser like I am here, just wildly and all over the place. But as you get close to lines that you need to keep, stop, cover them up, and then use the shield to finish things off. Okay. In the end, we should have a drawing that's got very dark lines for the figures you drew, and either very light lines for the layout, like mine are very light, or lines that maybe weren't so light that you erased. Okay. And then resist the urge to take your hand to brush away the crumbs, because we know that crumbs in our hands aren't very clean, even if we just wash them. They've got oil on them and dust, so use the brush if you're going to brush away those crumbs. And that'll keep your drawing smudge-free. All right, so that's drawing 2.5. Those are the 4 geometric constructions of inscribing a hexagon, circumscribing a hexagon, creating a hexagon off a base, and drawing an octagon within the square. Your last task will be to go to the bottom, add 2 light guidelines down here, and then letter your name after the words drawn by.